Okay, so our goals here is to learn what slope is, how to find it, how to identify different kinds of slopes if you're looking at them. I like my little collage here, examples of slopes in the real world, right? We have ski slopes. Is that what they're called? Ski slopes? Yeah. Here's one. Yes. Here's another one.
So now we have a title.
No, just doing slopes right now.
Just slide going into a pool. Where?
Right there.
Right, we have slides. Slides have slope. A roof can have a slope. Climbing downstairs or a ladder can have a slope. Here's some more stairs. Slippery slope. Yeah, these are signs. Slope. I mean, what does that mean, slope? Slippery slope. It's an English word, so what does that mean? Like a ramp. Yeah?
I'm going to say that.
A ramp? Yeah? Anything at an angle. So it has some kind of incline, maybe. Anybody ever been to Pittsburgh? This big giant incline over there like several years ago? It's like they take you up this big giant like hill or mountain, and it's like this. It's called an incline. That's a big slope. So we're learning about slope. So let's look at some words first. So what is slope? Guys, I really need you not talking. Okay? Slope is a quantification of steepness. And what is a quantification? Quantity, right? Quantity is a number, right? So it's a way of giving a number to a steepness of something, of a line. Okay, so we're quantifying it. How steep is a line? And by seeing that number, we get an idea of how steep the line is. And slope is actually a ratio. Okay, tell me what a ratio is. What's a ratio?
So it's like
Yeah, like if we wanted a ratio of boys to girls in this room, I'm almost afraid to do it. So what would be a ratio of boys to girls? Somebody count up the boys, somebody count up the girls.
You know, you want to guess there's
It's more than two. What have we got here? Our ratio of boys to girls.
Yeah, you're going to call Oh, I took two. That's 2 to 1.
You're close.
14
Yeah.
6.
So yeah, this explains a lot, right? We got 13 boys and 6 girls, right? Does that tell a story? I think it does.
14.
It's 14, no.
It's 13.
13. I did it. Alright, so that's what a ratio is. We're kind of comparing two things, and we compare it either using this like colon or a fraction. Yes? Now let's pretend that there were only 18 people here. Let's say some boy decided, that's it, I'm done. Never coming back. And then it became 12 to 6. Now would I write my ratio like this? How would I write it?
2 to 1.
2 to 1. You always reduce, always reduce, always reduce. When do we reduce?
Always. All the way.
Okay.
Every single time.
So now the ratio that we're actually looking at with slope is a height compared to a width. Now you think of a height as being up and down, and you think of a width as being left to right. Vertical means up and down, horizontal means left to right. How do we remember that? If you think about, we stand upright and we have vertebrae in our back, up and down, right? The horizon is in the distance where, say, the sky meets the ocean, right? That's going to be this kind of left to right line. Vertical over horizontal. Here's an example of maybe using slope here. So I've got my roller coaster. And whoa, that looks pretty steep here. And I want to find the slope. And basically what this means, so for every so many moves up, I go so many right. And then it's going to be the same moves up and the same moves right all the way. That's kind of what I mean by ratio of height to width. Now I figured out what the height is to go from here to here. So the height, when I did that, 56 feet. And then the width is 42. So it says for every 56 you go up, you go over, or to the right, 42. So how do I find a number that I can assign to this steepness? Yeah, what would I do? Huh? Well, yeah, let's set it up. I need the height over by the width. Right? So there it is. I set up the ratio, and like you told me before, you have have to reduce it, right? Oh, can I reduce that thing?
Yes.
Yeah.
Yes.
4/3.
8.
4/3.
4/3.
Well, which is it?
4/3.
Do they have a common factor?
4/3. 4/3.
7? Well, that's a point.
It's
That
4/3.
is 6. Oh, we can go some more.
4/3.
So, ladies and gentlemen, so do I change this to 1 1/3? Do I change this to 1.3 repeating? No. Why do I not? Now, I've been making a big deal about, don't give me a mixed number, don't give me a decimal. Why don't we change this thing, Ryan?
Because then it's just easier to go up 14 and write 14.
Yeah, now I can see my ratio. It's hard to see it here, it's hard to see it here. My ratio is, for every unit up, for every 4 units up, I go 3 units right. Every 4 units up, I go 3 units right. So that's the slope, okay? That's the number I'm assigning for this particular steepness. Now what would happen if we're going down this crazy roller coaster, and the next hill that we come to, it's not the same height, I mean this, that's still 42 feet, but now it's even higher. It's 14 feet higher. So now what is the whole height here?
70.
70 feet? I knew it. So now what's the slope? So now I do the height, which is 70 feet, over my width of 42 feet. Notice how the feet are canceling out, so there's no units here. Now what's that? Oh, I can see the 7, right? It's probably better than that.
10.
Okay, I can see more.
5/3.
5/3.
Which is bigger? 4/3 or 5/3?
5/3.
So let's think about this. So that hill is steeper, isn't it?
Yeah.
Which hill is scarier? The first hill? Or the
first
next
hill.
one where you're 14 feet higher?
Next one.
I'm scared of roller coasters.
Okay? Look at the numbers. This is a smaller number than that one. So as you get steeper, what happens to my slope? It gets bigger. That's exactly right. So as the slope gets steeper, so if it's more steep, you're gonna get a bigger slope. Now how big can that get? Now I hear tell of crazy amusement parks where you're straight up and down.
Yes.
Yeah.
Griffin.
Now I'm just,
Yes.
and you go on these things?
Yeah.
Yeah.
It's like
Yeah.
this. You're hanging on the edge. I have to go through a bridge.
Yeah.
Why do you do this?
I went
I have no idea
It's
why
fun.
you want to do that.
It's fun, it's entertaining. It makes people scream and people scream is funny.
Yeah, I think straight up and down, I'll tell you that. So, let me think about this. So as you get steeper, the number gets bigger. Now, if I go past there, now I know there are some where they kind of make you do this, but if you think about it, wouldn't the slope of this one kind of match an equivalent slope on that side?
See.
Yeah, it's just kind of on the opposite side. So can I get steeper than straight up and down?
Yes.
No.
Yes.
You just don't know.
You go like this and then you go in.
Now I'm talking about, you can think about how actually steep is this line? The steepest we can go is up and down. And if our numbers get bigger as we get steep, then I have to assign the biggest number to steep. Got that? Yeah. Because this number, it's going to match the one on the other side. It really isn't equivalent steep, but it's just kind of on the other side. So I have to think about what the biggest number is to assign to that. But we'll get to that. So slope is, it's changed in the height or it's changed in the width. So a little bit more mathematical here. Slope is a ratio. So if we're looking at some straight math here, I've got a coordinate plane and I've got a line on it. So it's still just like the roller coaster. It's how many up and how many right or left do I have to go to get from point to point. So we call that the rise. That goes up and down because we rise, we go up and down, and we call the left and right the run. Or some people do. I rarely will say rise over run, but it's very popular, so I wanted to kind of make sure you've heard of that before. Some people, that helps them remember it's vertical over horizontal. Rise over run. Well, how do you find a vertical change? Let's put numbers to this. So let's say this number here is 3, and this number here is 7. What is that value? 4. How do you get that?
You go up 4 times to it.
Yeah, it's like you hop over 4 times, you're at 7. So think about that. What's another way I could have gotten 4? 7 minus 3. So the way you find the change from this height to this height is you're really going to subtract the y values. 7 minus 3, that one's 4. Yeah. Now think about the horizontal change. That's going from here to here. We want to know what that change is. Let's say this one was at 5, and then this one was at
5 minus 5.
So what is this value in here? How many hops between 5 and 10? 5. So how do you get that? You subtract them. So we say the vertical change is, you look at kind of the values, the vertical change is you take the difference of the y's and you subtract the y's. And the horizontal change is you take the difference between the x's, subtract the x's. Okay? Because you're going to have like a funny looking formula, but this is where it's coming from. So let's see what I got here. For some reason, and I don't know why, and I keep asking somebody to go find this out for me, and nobody will. We use this letter M to mean slope. I don't know why. M, so if you see an M, it means slope. Yeah, it is, but why M? I don't know. So you find slope by creating a ratio of the change in the y values to the change in the x values. So you find 2 points on the line. The rise is the difference in the y values. I thought I'd throw in that word again. Remember that word? For y value, remember that? And run is the difference in the x. Remember this word? Abscissa. Right, just throw them in. Just a vocab. So we have a formula. This is what it is. So when you first look at it, you're like, what? All right, M equals, because M is our secret letter for slope, and it's not so secret, we know that. Because even I'm talking about slope, I want to know the change in the y, the vertical distance, which over the change in the x's. How do you find the change in y's? If you have 2 points, subtract the y values, and over those same 2 points, subtract the x values. Now this little triangle here is not a triangle, it's more Greek. Yay! It's a delta. So we did a lot of Greek with statistics. We have a lot of Greek in math. This is a delta. And if you kind of look at it funny, you can almost see a D shape. Our D comes from that delta. Delta y over delta x means the difference in the y's over the difference in the x's. It's a shortcut way of saying it. So I'm going to say, at first, I want you writing this out a lot until it's in the brain, and then it becomes a pain to write it, and then you can go to this, the shortcut. So I use both so that you know what I'm talking about here. What's interesting, I think, is that slope for a line is a constant value, which means if you pick any 2 points on a line, on the same line, and you run it through this formula, you always get the same slope. Because it's describing, I have to go so many up and so many over, so many up and so many over. And it's that same ratio all the way up and down through the line. That make any sort of sense? Yeah, yes, sir.
So if you made a line like 1 and 2, and you just plot any 2 points on a line,
Yes.
like 2 and 4, 3 and 6, they would all work and make the same
Yes.
line?
Yes, same slope.
Yeah.
You would get that same ratio every time. That's cool. Alrighty, wow, look at this thing. Okay, so let's do some examples here, and this is kind of the middle of your notes here. I think I filled out the first one for you, but let's see what I'm talking about here. This is, I have 2 points, right? And if you graph 2 points like I did here, and you connect them, you get a line, correct? So can I find the slope of this line now that I know 2 points on the line? The answer to that question, yes. I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1. So what you do with your points here is you label one of them your x1, y1. Here's my first xy pair. And then you label the other one your x2, y2. That's your second xy pair. So that's what we mean by x of 1. I have 2 x values. It just tells you which one's which. So let me just write them out formally here. So what's x1 in this example here? And what's y1? Right, it's just this value. And then what's x2? And what's y2? Now what would have happened? Is this allowed? What if I would have said, I want this one to be x1, y1, and this one to be x2, y2?
No.
Yes, you can. It does not matter which one is x1, y1, and which one is x2, y2, as long as your ones match up and your twos match up. I'm going to put it back the way it was because I didn't mention the notes. But you can pick either one to be first, either one to be second. It does not matter. I'm just putting it back the way it was. Okay, so now I want to put it in my formula. My formula says slope equals y2 minus y1 over x2 minus x1. This is what we did on the warm-up, right? We're just going to substitute in. What's y2? This. What's y1? Now I need x2 minus. Okay, now look at this. X1 is -4. These are subtractions. Be careful, and I'm writing it down, which means you should too. Be careful with negative numbers. Wherever you wrote that, maybe circle it and put some like stars and exclamation points. Because it's not that this is such a difficult formula, but subtracting, and you're working with negatives, you got to be really careful. Because when you subtract two negatives, what are you really doing? Adding. And I think of multiplication with a negative times a negative. Positive. So what is this? This is 6 minus 2. 2 minus 4. That's 2 plus 4. 6. And am I done? No. 2/3. 2/3. So my slope of this line is 2/3. Yes, sir.
Wait, so,
Okay. Let's try another one now. X1, Y1, X2, Y2. If you made this one X2, Y2, and this one X1, Y1, it will still work.
Oh.
If somebody wants to try it the other way, just to see what happens, maybe do that. Anybody willing to say, I'm going to number mine the other way? Anybody want to try it? Put it out. Go ahead, Ben. You make this one your X1, Y1, and this one your X2, Y2. Oh, brilliant question. Say that louder.
Doesn't matter if you do x1 minus x2.
Okay, so what if I made my slope formula do this? Y1 minus y2 over x1 minus x2. Can I do that? That's a great question. What do you think?
yes.
Why?
Because just one is the same as addition.
Well, I can. Well, you know why I can? Because remember I said you can just mix up which one's which? Isn't that essentially what this is? This is saying mix them up. You know what I can't do? Here's what you can't do. Y2 minus y1 over. What's wrong with this one?
They're both 0.
No, they're not zero.
Oh, they're 2, 1, 1.
Look at that. I've got a 2 minus a 1 and a 1 minus a 2. Do not do that. So what this basically says is you have to subtract starting with the same point. Don't mix them up or your sign is incorrect. All right, let's finish this one. Now you're going to do this different than me, right, Ben?
Number B, I got it.
Well, we're not there yet. Okay. So we're doing it this way, right? X1, Y1, X2, Y2. So there's some of this. This is a great question, though. Okay. So M equals, let's do it his way. Let's try Y1 minus Y2 over X1 minus X2. Let's see what happens. Y1 minus Y2. 5 minus -1. You have to be really careful with your negatives. Over, we're doing x1 minus x2. 3 minus 6. So did I do that right? 5 minus -1, 3 minus 6. Minus is a plus. 5 plus 1, 6. 3 minus 6, -3, which is -2. Yes.
I did it the other way.
Uh-huh.
And I got -6 over 3.
Okay. She got -6 over 3. What's -6 divided by 3? Does it matter where the negative is? Let's do that. We just keep talking about, what's the difference between this, and this? What's the difference between all these? First two, yes?
I have a question.
Can you hold it for 1 second? Remember your question. I just want to get this answer because this is a problem I keep seeing. Yes? Yeah.
The first two will equal negative X number,
Yes?
then the last one will equal positive.
Yes. Negative over positive is negative. Positive over negative is negative. Negative over positive is negative, yeah. And negative over negative is positive. So this and this are equivalent. You can put it in the top, you can put it in the bottom, or you can put it just out front. They all mean the same thing. So when you got negative 6 over 3 and we got 6 over negative 3, same thing. Yes?
Would you say X2 minus X1 over Y2?
No. It is always vertical change over horizontal change. If you put the x2's on top, that's horizontal over vertical, it's not the same one. And I'm sorry, Didi, what was your question?
If you're doing it and you got on a number, would you do it over 1 or just
Oh, that's a good question too. If on a test that I ask you, what's the slope? This is the simplest form, that's what I want. Now we're going to be using slope for other things. There may be times you want to see it as a ratio, and in that case we would put it over 1. But if I say, what is the slope? I want simplest form always. Thank you for asking that. Yes, sir.
Wait, so you can do Y1 minus Y2?
Yes, over x1 minus x2, as long as you're subtracting the same way. Can't mix them up. Yes.
Are ratios and fractions equal or?
Ratios or fractions? Are all fractions ratios? Maybe. Is that very philosophical question, actually. I don't know how to answer that in absolutes. Sometimes yes, sometimes maybe no. I'll tell you this, slope is always a ratio. Okay? It's always a ratio. And I guess we want our ratios to be fractions, even if we don't always express it in fraction form. Alright, let's just do this one real quick. Negative 2, 4. 4, right? So slope is y2 minus y1 over x2 minus x1. And for a while, I want you writing out that formula until it's really in your brain. And it will be. But we have to kind of get there first. So 4 minus 4 over 4 minus negative 2. So that is 0 over 4 minus minus is a plus, right? 6. Is this simplest form? What is 0 over 6?
0.
Now let's think for a moment. Slope is 0. Look at this line. What kind of line do I have here?
Horizontal.
Horizontal, perfectly horizontal. Remember what slope is? It's a measure of steepness. How steep is a horizontal line? Think about it. 0. It's making sense, really. And then as you get steeper, you get some number bigger than 0. Slope is 0. All right, moving on here. Things to know about slope. A positive slope, please stop talking whoever is talking. A positive slope is a slope that increases. As the x's increase, so do the y's. Think about you traveling along the number line left to right. If you're going up, you have a positive slope. If you are going down, you have a negative. As x gets bigger, y gets smaller. That's a negative slope. We also have this 0 slope. And we went and when we did the math, it came out to 0 because look at the difference in y's. y2 minus y1 is 0. 0 over any number except for 0 is 0. There is no tilt here. None. How much key and work on this thing? Right? You ready to go flat, right? You're going to nowhere. You're not going anywhere. Well, you got to, gravity's not helping you. So this one, you got to do something else. 0 slope. Easy to walk on. It would be a bad roller coaster. It would not. I would rate that one, though. I would not be. Okay, now an undefined slope. Now we talked a little bit before about we're assigning numbers to steepness, right? There's 0 steepness here. This is as steep as it gets. I can't get any steeper than that, so I am going to assign the biggest number we have to this. And the biggest number we have is
5.
yeah. Infinity's not a number, it's a concept, right?
Um,
What's the biggest
Never
number?
happened.
One is the biggest number, really? What's the biggest number in the real number
Quadrillion.
system?
All real numbers.
That's not all real numbers. I want a number.
Quadrillion.
I can always, and I can do quadrillion in one, right? I can always get one bigger. Is there a biggest number in the real number system? So I cannot even assign a number to it. So it's undefined. When you see a slope that's straight up and down like this, picture ski. Mrs. Grieser going skiing. You watching me? What's gonna happen? I try to ski on this thing.
You're going to fall.
You're just gonna fall down.
There's gonna be a big flat of Mrs. Grieser on the bottom, right? So this is picture this flat. They're like, oh, that's, I like that picture. They love that. So that's you not surviving. So 0, I like this one. Easy. Undefined, that's the one where you kind of fall real flat. I cannot have a biggest number. Now, what if I tried to use the slope formula here? Let's try the slope formula. So m equals y2 minus y1 over x2 minus x1. So if this is point number 1 and point number 2. So what's y2? And what's y1? What's my x2? And what's my x1? All right, 1 minus 5. 3 minus.
Oh yeah, if you divide by
Oh, wait, why am I cringing?
2, you divide by 0.
Cannot divide by 0. In mathematics, this is undefined. So see how it works? Works at all levels. Mathematically, we can't come up with a number. Why? Because there is no biggest number to describe how steep that is. So let's kind of review what we just did here. Is this slope positive, negative, 0, or undefined? Right, what is that? Yes. Is it positive? Negative. Negative is if you're going left to right and you're going down. This is a negative
I have a
slope.
question.
Yes.
Why don't they just use percent for like slopes?
You can turn the ratio into percent, but they don't. I don't know.
Okay, then you could just do.
Oh, you'll actually see why, because we're going to use this ratio to help us do other things, and the percent won't help us. Some people do. You can turn any slope into a percent if you want. Sometimes they'll say, oh, steep hill has percentages, blah, blah. That they turn the slope into a percent. But we're not using it that way. Oh, positive, negative, 0, undefined, then. Positive, I'm going up, it's increasing. All right? Positive, negative, 0, or undefined, Claire? 0 slope, right? You can walk very well on this. Positive, negative, 0, undefined, right? Undefined, that's your slope. And again, you can use the slope formulas on any of these, and the sign will tell you, what's the slope of this guy? Oh, I can barely read it. So I want y2 minus y1 over x2 minus x1. What is, what's this one say, 5? 5 minus, what's my y, negative 1? Over 3 minus 6. What does that say? I can't read it. Well, 5 minus negative 1 is what? 6? 3 minus 6.
Negative 3.
Negative 2, see? Negative. So it will tell, the sign tells you what it is. This one you're going to get a positive number. This one you'll get 0. This one you'll get a divide by 0, undefined. Alrighty. Finding slope given a table. Again, here's my handy slope formula. Sometimes you'll get a linear equation in table form. Like when we graph the table of values, right? We get this table. So these are all some xy pairs in a line. How can I find the slope? What do you think? Plug it in. Plug what in? Well, first of all, I need 2 points, right? Slope says you need an x1, y1, and an x2, y2. I need 2 points. Where am I going to get these 2 points from?
First 4.
Well, give me 2 points from this table.
5, 4, 8, 10.
5, 4, and 8, 10. I heard that. Okay? So if this is my x1, y1, and this is my x2, y2, could have labeled it the other way, does not matter. y2 minus y1 over x2 minus x1. Let's see what we got here. That would be 10 minus 4. over, let's see, 8 minus 5. 10 minus 4 is 6. Oh, wait, 3. Is that 2?
Yeah.
Is that right? Okay. Great. I know the slope of this line, it's 2. Now, wait a second. Is this your question?
Yeah.
What if I pick 2 other points? What if you didn't pick those? Does it work? So, did you pick 2 other points? Okay. Okay. Picking 2 other points. So, it doesn't matter who's x1, y1, who's x2, y2. Okay, just picking them. y2 minus y1 over x2 minus x1. So here's y2 minus y1. So that's 28 minus 22 over x1 minus x2. 28 minus 22? 17 minus 14? 2. It does not any 2 points on a line work. Right? They do, they work, yes. Any 2 points. That slope will be constant for any 2 points on the line. It's the same lines over lines.
Even 17.
Pick any 2 points on that table, you see it'll work. This little example here, which I don't even have on your paper, it's just maybe a slightly different way of looking at it. I think I'll do this example real quick here. What if I know the slope, and I know one of my x1, y1, but I only know the y, I'm missing a coordinate. Can I find this?
Yes.
Why not? Let's call this one, why not? Why can't we find it? I'm going to use my slope formula. M equals y2 minus y1. Yeah? So what's y2? What's y1? 3, right? I got those. Remember, you're not subtracting from the same point. It's the y's, and then it's the x's. Well, I don't know what that one is. But that equals my slope. What is my slope? I told you what it is. It's 3 halves. And luckily, we are all over solving equations like this. Aren't we? Well, first of all, 9 minus 3, I can reduce that. How do you solve an equation like this? Oh, what do you do? Ryan, what do you do here?
You do the cross multiply.
Remember the cross product? This times this equals that times that. Before I do that, what must I do? Put what in parentheses?
X minus 2.
Thank you.
This
This minus this times that.
How'd you get 2 there?
How'd I get to where?
On the x minus 2.
How'd I get it? Because it's x2 minus x1. So that was an x minus 2. Right? You do y2 minus y1 over x2 minus x1. Yeah, I just put it in the formula.
Oh, I thought it was 2.
All right, look at me. So I guess we could do this. We could distribute to do something more sneaky. How about if I divide by 3? I'm gonna be a little sneakier. If that gives me 1. X minus 2. 6 over 3 is 2, right? So x minus 2 is 4. Add 2. 6.
You can't solve it.
So you can do kind of cool stuff if you're quite ready. If you're not ready for this yet, don't worry about it. Don't worry too much. Yes.
You said why not?
Why not? I said, why can't we do it? Why not? Sure. So we did it.
You can do it.
You can.
Wow.
Yeah. Alrighty. I'm up to some neutral. How are we doing? Are we getting there? How do we do? Did we get 2 for the first one? Did we at least get through the first one?
Yeah.
Anybody have a question on the first one?
I got one.
Yeah. How do you get it? What? I'm we're at the top of the page. Top of the page.
Yeah.
Let's get 2.
Yeah, so now you're listening, right? Okay, All right, let's review. This is x1, this is y1, this is x2, this is y2. Slope is y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2, don't care. All right, so that means subtract the y's. 9 minus negative 1. We're being careful with those negatives. Then we subtract the x's. 3 minus negative 2. Negative, negative is a plus. 9 plus 1 is 10. Negative, negative, that's a plus. 3 plus 2 is 5. 10 over 5, 6.
We go over 60.
See? Find the slope. Now I gave you a table, so what do you have to do? Pick 2, so what'd you pick? Negative 2, comma 5, and negative 7, whoops, negative 7, comma 8. Now when you write a point up and down like this, it's almost a little easier. So if I'm going to subtract in this direction, what's my change in y's there? 8 minus 5 is 3. And now I'm going to do my change in x's. Negative 7 minus negative 2. Let me write that one down. Negative 7 minus negative 2. Well, that's a plus 2, right? It's negative 7 plus 2. So I got 3 over negative 5, which is the same as negative 3/5. Isn't it?
Yeah.
Because a positive divided by a negative is a negative. Negative 3/5. It's not wrong, but this tells me, I get it, this is a negative number. You could have said negative 3 over 5. If you would have subtracted the other way, you did 5 over 8, then negative 2 minus negative 7, you did it that way. But aren't they the same number? All these three things are the same number. Okay? Yeah? Can I move on? Who still has a question? Yes? Yes.
Instead of doing this,
Well, let's see. 7 minus y over 2 minus 0 equals 1/2, right? Simplify the bottom there. So I'm getting 7 minus y over 2 equals 1/2. Instead of distributing, you can multiply both sides by 2. Right? And that'll knock this up, that'll knock that one. 7 minus y equals 1. Subtract 7. So negative y equals, well, that's minus 7, right? 1 minus 7 is negative 6. I don't want negative y. How do I fix negative y equals negative 6? Multiply both sides by negative 1. We'll flip your sign. So y equals 6. There it is. Right? Extra, you got this, kudos, right? This is hard. I'm really most concerned about those top 3. Okay, now that we're experts on slope, right?
Yeah.
I'm not an expert. It's a y2 minus y1 over x2 minus x1. It gives a number to the steepness of a line. We're going to talk about rate of change. A rate of change compares a change in one quantity to a change in another quantity. So it's a ratio of how things are changing, which sounds an awful lot like what slope is. Because slope compares the change in a vertical over change in a horizontal. Slope is a rate of change. And we treat rate of change problems like slope problems. So we use rate of change in real world problems, real world stuff. So when you do real world stuff with rate of change, we often use time as one measure. So miles per hour, right? That's a rate of change. Kilometers per second, rate of change. So time is very often in there. In science class, you learned about independent and dependent variables, am I right? So Mr. Luke today, he said, yep, I just taught that. Yeah, Mr. Luke, did you talk about rate of change, independent, dependent? Yeah. So what is it? You get this right, I'm telling Mr. Luke. So what's an independent and what's a dependent?
Independent variable is what you know. Is what you change. Dependent variable changes. So dependent gets affected by dependent gets affected by
Dependent depends on the independent, right?
Well,
Yeah, so independent time is always an independent variable, I think. It like changes, and then based on what time it is, that might affect something, right? So distance might be affected by, well, what time is it? If it's a long time, maybe I'm farther away. So time is always independent, and if you're graphing things, where does the independent go? On the x-axis or the y-axis?
Y-axis.
The independence is always the input. How about that, right? So the independence always here, and the dependence always here. So the x value is kind of where time goes. So if you see time, that's the next value. And let me just do an example here. Yeah, since I'm here. So this is a table. It shows for time how much distance somebody walks. Somebody likes to walk for their exercise. So I want to find a rate of change in distance with respect to time. So what am I changing? I want to go distance with respect to time. So if you think of slope, which is change in y over change in x, what's the y and what's the x? Its slope is change in y over change in x. Who's the x value here?
The time.
Time. Who's the y value here?
Distance.
Okay? So if I know who's x and who's y, I can solve this thing. So it's change of distance and change of time. The secret here, come up with 2 points and then just use slope. What are 2 points I can come up with here? Yeah, what do you want to use, Ryan? Making sure this is time and this is distance, because that's the x, that's the y. Now it's just slope. y2 minus y1 over x2 minus x1. Okay, so let's go this way. 3 minus 1.5 over the x's, distance, different, 60 minus 30. Yeah, 3 minus 1.5 is 1.5, and 60 minus 30 is 30. You said you can't have decimals. In real life problems, we're going to do that, because you know what I should have put here? My units. This is, what's my distance is in miles, and my time is in minutes. So this is still miles over minutes. What's 1.5 divided by 30?
1.5.
What is it? 0.05, what's my unit? Miles per minute. So what's their rate that they walked? They walked 0.05 miles per minute. So for every minute, it's 0.05.
Oh.
It's slope.
Oh.
Rate of change is slope. Okay? So you're using rate of change uses slopes. That's how we find miles per hour in a car. It's slope. Slope, really. Let's see what time it is. I guess we could try this. This is using slope here and rate of change to kind of analyze a graph a little bit. So community theater performs a play every Saturday for 10 consecutive weeks. The graph shows the attendance. What I love about this is it tells a story. Think about the rate of change from week 1 to week 4. Now, what kind of slope is this? Positive, negative, 0, or undefined? Positive slope. What does this say about the attendance based on what week we are? Yeah.
It's going up for.
Our attendance is getting better, right? Now, what happened between week 4 and week 6? Positive, negative, 0, undefined here. It's negative. It's starting to go down a little. Now look at this. It's a flatter slope. It's not as steep as, say, this one. So it's slowly kind of decreasing. Now what happens between here and here? We're getting a steeper rate of negative, right? Isn't this one, just looking at it, steeper than that one?
Yeah.
So it's going down faster. So we can actually tell a story by looking at these little graphs here. Now we can find exactly what the rate of change is between weeks 1 and 4. I'm just looking at these points that I can barely see here. So let's see. 230. There's your x1, y1, x2, y2. So we can go and find these slopes. So what's my y2? 232 minus. This one, 124 over 4 minus 1. Oh, what is 232 minus 124? 232 minus 108.
108.
Over 3, right? What's 108 divided by 3? 36? 36 what here? What happened here? What are my y values? That's the people, right? And then what is my x value? 3, right? So it's 36 people per week. Bigger. So my attendance increased by 36 people per week.
Oh.
Yeah. And then now I want to see how it decreased here from weeks 4 to 6. Well, now I'm going to find the slope of these 2 points. So I want y2 minus y1. 232 minus, is that a 204? I think it is. And then I've got a 4 minus a 6. I'm just doing y minus y, x minus x. 232 minus 204, what's that? 4 minus 6. So what's that? Negative 14 people per week. Why is it negative? Why do you have a negative purple? What does that mean? It's going down. So we're losing 14 people per week. Here, losing them. So a negative slope has a value. And then what happened, this final run here, let's find the slope. Subtract the y's. I think that's a 72. And then subtract the x's. 6 minus 10? Know what it says? I think so. What is 204 minus 72? Do it for me. Negative 132? Well, it's positive, right? And then 6 minus 10 is my negative 4. What happens there? What's the 132 divided by negative 4? Negative 33. So now this one I'm losing 33 people per week. So first I increased 36 people per week, started decreasing 14 per week, then decreasing 33 per week. So it tells a kind of a little story here. Yeah. And now we come to rocket science. Oh. That ain't rocket science. Yes, it is. This is rocket science. So I've got a missile, and it's 2 miles above the Earth, 60 seconds after the launch. And it's 6 miles above the Earth in 3 minutes after launch. Whoa! So what's the rocket's rate of change in miles per minute? Are you kidding me? Yes. She found 2 points. How did you do this? How do you know who's X and Y? How about that? All right, ladies and gentlemen, I hear too much talking. I'm amazed. She just did a fantastic job here. So somebody was listening. She said, oh, you need 2 points. So let me find 2 points. And I see 2 miles and 60 seconds. I also see 6 miles and 3 minutes. Now, the thing that we have to be careful about, though, who's the X value and who's the Y value? Now, how do you figure this out? See this miles per minute? I'm writing that as a fraction, miles per minute. That's my change in Y over my change in X. So who's the X? The minutes. Who's the Y? The miles. Okay, so let me see here. This one says, basically time, right? Well, 60 seconds. Oh, wait a second. 60 seconds. That's not a minute. What is that? 1 minute. Yeah, so make sure if it's in minutes, you want to be in minutes. So there's 1 minute. And I'm 2 miles. And then the other one, 3 minutes, I am at 6 miles. I'm just going to find slope. Change in Y over change in X. 6 minus 2. I'm going to put my units here just to make sure I did this correctly. It's easy to mix these up and have the wrong thing the X and the wrong thing the Y. So 6 minus 2. 3 minus 1 minutes. 6 minus 2 is 4. 3 minus 1 is 2. Miles per minute. Well, wait a second. 4, oh, that's 2. So we're going 2 miles per minute. Which, we're walking, I don't know, is that fast? I don't know. Yeah, it doesn't sound very fast. What? Yes, it does matter who's X and who's Y. Because if you switch these, you're going to get minutes per mile. What? That's not rate of change. We do miles per minute. We do it with respect to time. Time's our independent variable. So you have to think about it. Now sometimes they don't say what you want. What if they didn't say? What if they just said find the rate of change? You would say, what makes sense? Miles per minute or minutes per mile? What makes sense? Miles per minute. So you have to kind of think about it a little bit. And we are getting there, almost there. All right, so I try to put your U-trace here. This is straight up just review finding the slope. And then we've got some rate of change type stuff here. Okay? So give it a shot. Give it a shot. Some of you already have done the first 4. If you've already done the first 4, check your answers and let me know if you have a question. 4B. No, again, you had all kinds of great questions today. Repeat that question. Like you did the slope and you got something like this, right? And what was your question?
Should we write undefined?
Yeah. Should we leave it like this or should we write undefined?
Leave undefined.
Yeah. Why do I not leave it like this?
Because
Why not?
that's just applied.
It's not even a number, right? 3/0, it's not even valid mathematics. This is like, what? You have to tell me, no, that's not a number. This is undefined. So here's the story. If you're taking a test, say, and you figure this out, and you say, I got it, it's 3/0, I am marking it wrong because that shows that you don't get it. This is an undefined slope. This is a straight, graph these things. You got -1/6. Look, it's a straight up and down. I can't write a slope for that. Yes.
For the units.
E, question on E. Do you have to put in the units? What do you mean? This is where units are so critical. Why are units so important? Because you have to make a decision here. Now, I can see some points. I need 2 points, right? But do I say we burn minutes per calorie or calories per minute? Calories per minute. And I write down my units first. I start with units. Calories per minute. That's what I meant to say here. And that is your change in Y over your change in X. So what's your X and what's your Y? The X is the minutes and the Y are the calories burned. I need those units to start with so I know who's my X and Y. When I build my 2 points, pick any 2 points you want. Maybe you're doing this. Or maybe, pick any 2 points here. Find the slope. It'll be calories per minute. So you have to start with the units. Yes, sir. Well, let's see. So I'm going to subtract here, right? -5 minus -3 over 1 minus 4. -5 minus is a plus, right? -5 plus 3, -2. What's a negative divided by a negative? Yeah, be really careful with that. I hear all kinds of talking. You guys get this? Yeah. These are the mistakes I see on the test all the time. You guys are finding them now. Isn't that great? But only if you're listening. Okay? 2 minus 2, right? And that's changing Y. Over -3 minus 5. 2 minus 2 is 0 over -8. What's 0 divided by -8? 0. These two things are not the same. 0 can be divided by a number, but you can't divide a number by 0. So be careful. Yes, sir.
Letter E, how do you know, put calories over?
Well, because this is where like your brain skip. You say, would I say I burned so many calories per minute, or would I say I burned so many minutes per calorie? What would you say? Calories per minute. And the other thing is time is always your independent variable, always. So it's always going to be your X, whenever there's a time. Yeah? Now when you're doing rate of change, I would guess decimals because it's a real life question. And I'm putting up the answers here just so that you can check them. Yeah? If you get that link by missing those 2 points and who's X and who's Y, it's time to slow. So you really got to think about it at first, but then it's like, oh, the light bulb.